And now for section 7.1 on decimals. So to begin with, when you write a fraction like this, 1 over 10 or 1 divided by 10, we often call this 1/10. But the word right there also helps out when you're talking about decimals, because the decimal form of 1 divided by 10 is a 0.1 or 0.1. And so this right there is also 1/10. Now to expand that idea a little bit, if the number was 0.1, 2, 3, 4, etc., then this is the tenths place. And then this would be 2 over 100. So this is the hundredths place. So basically you write 10 and then put a THS. Write 100 and then put a THS. It's not usually the way that we speak in English. We don't usually say dths. But here we do, hundredths. And then this would be the, so you first start writing 1,000. And then put the THS. And this 4 would be the 10 thousandths. Or even another way to look at it is that number is equal to 1/10 plus 2 of them that are 1/100th plus 3 of them that are 1/1000th plus 4 of them that are 1/10,000th. Or even another way to look at it is it's a 1 and then this one is 10 to the 1. Next is 2 times 1 over 10 squared. 3 over 1 over 10 cubed. And then for 10,000, that would be 1 over 10 to the 4th. So then let's do some examples. So for example number 1, write this number in decimal form. So we'll do a couple of these, part A. So if it was 2 parentheses 10 plus 3 parentheses 10 to the 0 plus 8 parentheses 1 over 10 and then 9 parentheses 1 over 100. So it's basically right here that is dividing the whole number part from the decimal part. So this would be 20. And then this would be 3 times 1, so that's just 3. And then we would have the decimal part. And then this would be 8 in the tenths place and 9 in the hundredths place. Or in other words, this is 23.89. And then what if some terms were missing? So in here I did a 10 to the 1, 10 to the 0. This is 10 to the 1 in the denominator. This is 10 to the 2 in the denominator. So how about if it was 4 and 10 is squared plus 5, 10 is to the 0, and plus a 7 and 1 over 10 squared. So like with the last one right here is the division between the whole number part and the decimal number part. So this would be 100 when you square 10. So that means this is 400. 10 to the 0 is 1, so this means 5 times 1. And then for the decimal part, so this is missing the tenths, like this one right here. This one is missing it. So I need to put a placeholder 0 saying there are no tenths. And then there would be 7 over 100, so that's 7 100ths. So finally, my answer is, it's 405.07. So one small note, when you have a number that's less than 1, like if you have 0.83, so you could write it that way, or you can write 0.83. They both mean the exact same thing. The reason for the 0 right here is just to alert people that this is a number that's less than 1 and you should be looking for a decimal point. Because if somebody has sloppy handwriting and then they write it like this, and you just look at that quickly, you might say that's the number 83. But if there was a 0 sitting in front of it, you'd say, oh, 0. Brain then says there must be a decimal point right there. On to the next example. Now do the opposite. If you're given a decimal, then write it in expanded form. So for example number 2, write in expanded form. So this is basically doing the opposite of what we just did. So if it was 32.019, so you could start taking it apart. 30 plus 2. So there's the tens and there's the ones. And then there's going to be this imaginary dividing line between the whole number part and the decimal part. This is the tenths, hundredths, thousandths. So then there would be plus, I meant to write 0. 0 times 1 over 10 for 0 tenths, plus 1, that is 1 100, and plus 9, that is 1 1,000th. And then just to finish it up, this is 3 times 10, so it's 3 times 10 to the 1, and this one is 2 times 10 to the 0, and then 0 times 1 over 10, and 1 over 10 squared right here, and for the last one, 1 over 10 cubed. And that is perfect. Except for that little smudge right there, but that's okay, just ignore that. Then it could be that the students are given the problem in words. So for example, number 3, write this in decimal form. So the words are going to be 646 hundredths. So 100 means we're talking about whole numbers. Hundredths means we're talking about a decimal. So 600 is the whole number part. And then for the decimal part, 46 hundredths. So when you have 46 hundredths, you can write it like this, 46, and because the 6 lands in the hundredths place, that whole thing can be read as 46 hundredths. Of course, it could have been read as 4 tenths and 6 100ths, but that would just be like, for example, if you had a $5 bill, you could call that a $5 bill. Somebody else has 5 singles and they say they have $5 also. It's true. There's different ways to express the same thing. But the fastest way is when it's 46 100ths, you put the 6 down in the hundredths place, and then this is saying 46 100ths. And then the reciprocal of this problem, now write it in words. So what if it was that number right there? So the first part, that's 10. And then this would be the tenths, hundreds, thousands, 10,000s, 100,000s. So this is the 100,000ths place. So just like with the last one, you could say this number, and then this number, and then this number, or you could just say 179 100,000ths. So 10. Right here, it seems more natural to me to say and 646 100ths. Sometimes it's there, sometimes it's not. I prefer to have it there. 10 and 179 100,000ths. 179 100,000ths. Much easier to just write the number, but those are the words for it. Okay, next idea, put them in order. So if you look at decimals, then put them in order from the smallest to the biggest. So for example number 5, place these numbers on the number line. So how about point A, or number A, is going to be a 0.42. B is going to be a 0.042. C will be 0.37. And do I have enough space? D will be 0.037. And finally, E is going to be 0.307. So all of these numbers are pretty small. So when I draw the number line, I could start at 0. And then this is actually the biggest one, a 0.42. So I'm going to call that a 0.5 right there. So then this would be 0.1. 0.2, 0.3, 0.4, and then 0.5. So let's see. 0.42 means go to 0.4 and just a little bit to the right, and that's going to be A. So this one I'm now done with. Let's see, what's another one that's close to this while I'm working on this? So 0.37, so this would be 0.3. About right there is 0.35. So right about here is 0.37. So that is C. And this one, I think I'll do this one next. 0.30, and then just a little bit more. So this is 0.30, and then just a little bit more for that 0.7 part. So this is where E goes. And now for these two, they're 0.0 something. So 0.0 would be in here. If you went to 0.5, that would be right here. So 0.4, 2 is going to be approximately right here. So that's going to be B. And then finally 0.037, the 3 is smaller than the 4. So this is actually to the left a little bit. So this would be the last point, D. And then we're done with that example. Now convert between fractions and decimals. So convert to fractions first of all. So given a decimal, we'll do two parts. Part A, 0.12. So here's where the words come in handy. So this is tenths, this is hundredths. So this is 12 100ths. And all fractions need to be reduced whenever possible. This one can be reduced. You can divide this by 4 and you can divide this by 4. So divide each one by 4. On the top, it's going to be 12 divided by 4 is 3. On the bottom, 100 divided by 4 is 25. And a 3 will not divide into a 25 evenly, so that means this one is finished. Then for part B, how about 0.038? So again, use the words. This is tenths, hundredths, thousandths. So this is 38 thousandths. And then reduce. So I know this is an even number, so this can be divided by 2 and this can be divided by 2. So reduce by dividing by 2 and dividing by 2. And 38 divided by 2, that's 19. 1,000 divided by 2 is 500. And I can also use a calculator to check my answer. So take the decimal 0.038. And then I can go to math, and the first thing it will do is change it into a fraction. And it says you should have gotten 15 divided by 500, so that one's correct. Now work the other way around. Given a fraction, change it into a decimal. So for example number 7, convert to a decimal. Part A, how about 3 1/4? So you might just look at this and say 1/4. Well, a quarter is worth 25 cents. So that means that it would be 3.25. Or you could look at 1/4, and when you're using the decimals, all of these are either 100, 1,000, 10,000, something like that. So if I could get this denominator to be 100, then I could basically have this and work backwards and then know what the decimal is. So to make this be 100 right here, I would need to multiply by 25. And if you multiply by 25 on the bottom, you need to do that on the top. So then this is going to be 25 100ths, and then that can be written as 0.25. 25 100ths. Then for part B, how about 17/8? So is it possible to multiply something with this 8 and get 100? Or in other words, will 100 is 100 divisible by 8? It's 12.5 times. So that is one way to do it. So you could multiply by 12.5 and multiply by 12.5. I'm not saying that's the easiest way to do it, but that's one way to do it. So when I multiply on the bottom by 12.5, that's going to change it into 100. When I multiply the top by 12.5, that's going to be 212.5. Now, to finish this, when you divide by 100, oh, I forgot to mention. So with this little decimal right here, we can't just automatically change it to a decimal. We need to use a different idea. And that is when you divide by 100, that moves the decimal place 2 places to the left. So then this one would be move the decimal 2 places, so it goes right here, 2.125. And then that one's finished. Now, like I said, that's one way to do it. Here's the way that I would do it though. So redo that one. So this is still example number 7. What if it was 17 divided by 8? The way that I would do it is 17 divided by 8, so 8 will divide into it 2 times. So I could even show my work over here. An 8 dividing into a 17 goes 2 times, and then multiply, so this is 16. And then the remainder would be 1. So this is equal to 2 1/8. Okay, but then how are we going to get this 0.125? Well, just use this idea. In the last one, we saw that 1/4 is equal to a 0.25. And if I then multiply both sides by a half, then on the left side, you multiply on the top, you multiply on the bottom, it's going to be 1/8. And now this is really saying take a 0.25 and cut it in half. So how much is 2 divided into a 0.25? So you put the decimal right above where the decimal went, and a 2 will divide into 2 one time, and then multiply, so that's 2. Subtract 2 minus 2 is 0, bring down the 5. A 2 will divide into 5 2 times, so 2 times 2 is 4. The remainder is 1. And then, because we're not done with the division algorithm, we don't have a remainder of 0, then we need to put another 0 right here and bring down that 0. And then 2 divided into 10 goes 5 times. And now the remainder is 0. So then this side turns out to be the decimal 0.125. And then that would be the final 2.125. And now on to the last idea of this section. Does the decimal terminate? Or in other words, does the decimal end? So for example, 1/2 is equal to a 0.5. So right here, the decimal stopped. So what about 1/3? So 1/3 is equal to 0.333, and the 3's go on forever. So one way to say that the 3's go on forever is you put a little line over it, meaning 3's keep going forever. So this one, the answer is yes, it terminates. This one, no, it does not terminate. Now, how can you tell when you first look at the fraction? So we're going to use this fact. A over B the decimal form will terminate if, and then you just look at the denominator B. If B has only 2's and or, so it can be a combination of 2's and 5's in its prime factorization. And one other note is this fraction, in order for this rule to be in effect, this fraction needs to be reduced already. So, for example, number 8, does the decimal form terminate? So for A, so how about 17 divided by 505? So we just need to look at the denominator and then factor it. So 505, well, it ends in a 5, so I know it's 5 times something. And then 5 would divide into this 1 time, 0 times 1 time. So it's a 101. And then 101 is prime, so that means that it's not following this rule. So when you factor it, you should only get 5's and 2's. And then this is not even divisible by 2. So if we look at the decimal form, 17 divided by a 505, and then you'll see that the decimal just keeps going and going. It looks like the pattern would be 3366, 3366, 3366. It's got a nice rhythm. So the answer is no, it does not terminate. And then for part B, what about 7 divided by 112? So if you take the 112 and factor it, so this would be 2 times. 2 goes into 150 times, and 2 goes into 12 6 times. And then for 56, I could use 7 times 8. And suddenly my brain goes, wait a second, a 7? So that means 112 is divided by 7, and that's a 7 right there. That means this one has not been reduced. Oh, wait a second, you need to reduce that first. So this could be divided by 7, and this could be divided by 7. So this one needs to be reduced first, and that's going to be 1 divided by, and then a 112 divided by 7, that equals 16. So it's actually this fraction that we should be dealing with. And then 16 is 2 times 8, and 8 is 2 times 4, and 4 is 2 times 2. So this part right here is saying you're supposed to only get a combination of 2's or 5's, and this one has a combination of just 2's. So the answer is yes, this one does terminate. 1 divided by 16, so it terminates and stops right there at the 5. And then one last idea of this section. Example number 9. Express, or in other words, write these as decimals. And then what if we had something funky like 7 divided by 2 to the 2 times 5? Well, to write this as a decimal, it would be nice if the bottom was a 10, 100, 1,000, 10,000, because like the very beginning of this section, the first decimal place is the 10th, then the hundredths, then the thousandths, then the 10,000ths, etc. So if we could get these to be, the denominator to be one of these numbers, then it would be very easy to write it as a decimal. So right now this is basically 4 times 5. So that's a 20. So we actually need, if this is a 20, we need to multiply it by a 5. And if you multiply the bottom, you need to multiply the top. Now I'm going to throw in one extra step because on the top, it's 35. But here's the extra step. This is 2 squared, and this is 5 squared. And that's actually the key, is that you need to get these exponents to be the same. And then, when you do that, this is going to be 4, this is going to be 25, and 4 times 25 is 100. And then we've got it. So that is 35 100ths. So this is the hundredths place. So the 5 needs to land right there. And so this is equal to 0.35 or 35 100ths. And then just one more example like that. If it was 11 divided by 2 times 5 to the 3. So I'm going to skip to this part because this is really the key. This means that the 2 exponents need to be the same on the 2 and the 5. So this one already has a 3. Now you can't just throw an exponent on here. So what you need to do is, right now, its exponent is 1. So if I multiply by 2 to the 2, then when you add these exponents together, that's a grand total of 3. Now if you multiply the bottom by that, you need to multiply the top by that. So on the bottom, we now have 2 to the 3 and also 5 to the 3. And then this is the number 4. 4 times 11 is 44. So this is an 8 times a 125, or 2 raised to the 3rd times 5 raised to the 3rd. It's 1,000. So this is 44 1,000ths. So put the decimal, this would be the tenths, hundredths, thousandths. Now take the number 44 and put this last part of it right here at the thousandths. And so that would be the 44 thousandths. And now we're done with this section.